Some of you are better at Greek letters than I am. Is that Phi? It's supposed to be this Greek letter that's on the Unicode right here. And sometimes people draw it and it looks like this empty set. I'm drawing it like an empty set right now. But this is one of the most important functions in cryptography. To get us started, do you remember what it means for two numbers to be relatively prime? Two numbers are relatively prime if their greatest common divisor is 1. This is a relationship between two numbers. It's not a property of a single number. So sometimes people say something like 7 is relatively prime. That's not true. That's nonsense. It's true to say 7 is prime, but relatively prime, just like the name suggests, is a relationship. It would be correct to say 7 and 2 are relatively prime because there's nothing larger than 1 that divides both of them. So can you give me, what are two numbers that are relatively prime? Is it 8 and 9, 5 and 8? What else? 3 and 7? All of these are great examples of pairs of numbers that are relatively prime. What are some pairs of numbers that are not relatively prime? 10 and 4? Neither one, 4 doesn't divide 10 or vice versa, but it doesn't matter. 2 divides both. What's 9 and 12? What else? 5 and 10? Yeah. So all of these are examples of pairs of numbers that are not relatively prime. And you can use this concept of relative primality to define a function, which is the Euler Phi function, sometimes also called the Euler totient function. If you're going to do math, you must learn how to pronounce this person's name. No, it might look like Euler, but it is not. It is Euler. How many of you have heard of Euler before? Euler was one of the greatest mathematicians who ever lived. He had lots of intellectual interests. They weren't specialists back then. Laplace, who is also a great mathematician, is the one who said, read Euler, he is the master of us all. And Gauss, who is another great mathematician, said the study of Euler's works will remain the best school for the different fields of mathematics, and nothing else can replace it. He's the reason that we call the number pi, pi. He's also the reason that we call I. And he is the reason that we call E, although he didn't popularize that notation. And it's called E in his honor. So he came up with this function that's named after him. The definition of the Euler totient or Euler Phi function is phi of n is the number of positive integers less than or equal to n that are relatively prime to n. So this is not too hard to work out for our starting point. Suppose I wanted to calculate phi of 1. So 1 is relatively prime to any positive integer, and it's also relatively prime to itself, which is a bit strange. But phi of 1 is equal to 1 because there's one positive integer less than or equal to 1 that is relatively prime to 1. What about phi of 2? I have two candidates. I have 1 and 2, both of which are less than or equal to 2. How many of these are relatively prime to 2? Only 1. 2 is not relatively prime to itself because 2 divides both 2 and 2. So phi of 2 is equal to 1. What about phi of 3? So what are the positive integers less than or equal to 3 that are relatively prime to 3? What about phi of 4? I have 1, 2, 3, 4. Yep. So 1 is relatively prime to 4, and 3 is relatively prime to 4. All right, last one we'll do right now. What about phi of 5? Yeah, 1, 2, 3, 4, 5. All of these numbers are relatively prime to 5. So this is how you do the basic calculation. Now, in order to use this, we want to develop some properties. We don't want to always be in this situation where we're just crossing out things. I mean, it works for small values, but what we'd like to have are some properties. So if we think about properties of phi of n that this could have, when we think about this, it's easy to start with special types of numbers and see if we can go from there. So a starting point when we think about number theory, 2, 3, 5 that are prime. And we calculated that phi of 2 was 1, phi of 3 was 2, and phi of 5 was 4. Is there a pattern here? So phi of p is equal to p minus 1. P is prime. Can you give me a quick intuitive explanation of why that is true? We have 1, 2, 3, up to p minus 1, up to p. By definition, if p is prime, its only positive divisors are 1 and itself. So it's not possible for anything else to divide it